Conservations of energy in LC oscillation. Suppose we have a capacitor with a capacitance C, and this capacitor, let's say it is charged initially to Q naught. Now the energy in the LC circuit, it is initially stored in the capacitor, and that energy is UE equal half Q naught square upon C. Okay, so this is the initial energy which is being stored in the capacitor. Alright, suppose at any instant of time, let us say that at a time t, the charge left in the capacitor at a time t, let's say the charge left in the capacitor, let's say it is Q, and the current that is passing in the LC circuit, let's say it is I. So in this case, right, if Q is the amount of charge present in the capacitor, then the electrical energy at this instant of time will be 1 upon 2 Q square upon C. Or I can say 1 upon 2. Instead of Q, if you remember the value of Q, when we do that mathematical treatment of LC oscillation, we found that this Q is equals to Q naught cos omega t. So instead of Q, I'll write Q naught cos omega t. And then with a square outside bracket, and in the denominator we have C. Or this electrical energy at a time t can be written as 1 upon 2c. If you square this, you'll get Q naught square and then cos square omega t. Okay, this is my equation 2. Alright, so similarly, because at a time t, we have not just the energy in the capacitor, but also we have energy in the inductor. And that energy is known as magnetic energy. So the magnetic energy at a time t in the inductor is written as 1 upon 2 Li square. Okay, or I can say this is 1 upon 2 L instead of I. Again, we have seen before that I is equals to minus Q naught omega sine omega t. So putting this value of I here, you'll get minus Q naught omega sine omega t and then square. Or UB is equals to half L. If you square this minus, you get plus, and this is Q naught square omega square sine square omega t. Okay, so this is the value of the magnetic energy at a time t. Okay, now what is the total energy at this time t? The total energy at a time t is the sum of the electric energy and the magnetic energy. So therefore, total energy will be U equal UE plus UB, which means U equal, instead of UE, I'll write 1 upon 2C Q naught square cos square omega t plus UB is 1 upon 2 L Q naught square omega square sine square omega t. Okay, next what I'll do is I have to find out the LCM of the denominator. So here we have LCM as 2C. Okay, so the LCM is 2C. Making a cross multiply, you'll get 2Q naught square. Sorry, I think I made a mistake. This 2 with 2 cancels, so this you're left with C. So C times this will get CQ naught square cos square omega t plus. Okay, I think there is no C here. Sorry, it's again a mistake because this is 2C. So 2C times 1 is equals to 2C. So 1 times Q naught square cos square omega t, you'll get back this. So no C square. Okay, and here, right, this 2 with this 2 cancel, you'll have only C. So C times this will get LC Q naught square omega square sine square omega t. or this total energy is equals to, now this q naught square, I'll take common. So here you'll have only just cos square omega t plus LC omega square sine square omega t upon 2c, or u equal q naught square cos square omega t plus, okay, this omega square, it is equals to how much? 1 upon LC, isn't it? Omega square is equals to this, so you'll have sine square omega t. Now this with this cancel, so only u will be q naught square cos square omega t plus sine square omega t is equals to 1. So that means you'll have only just this much, or I can say this is 1 upon 2 q naught square upon c. So this is the total energy at any instance of time. Okay, so if you compare this equation 4 with equation 1, what we found is this energy at any instant of time, it is always the same as the energy in the beginning. Okay, see, in the beginning we have, this is the energy stored in the capacitor. Okay, that means the total energy at this time also is equals to this much. But at a time t, again the energy is same thing. So which means the total energy at any instance of time, it is always remaining the same. Okay, so this is about the conservations of energy in the LC oscillation.